Welcome to lesson 12.3, Geometric Series. Our essential question is, how do you find the sum of a finite geometric series? We're going to begin on page 613 of your book. Let's first go ahead and define what is a series. We've been talking about sequences, and now suddenly we have what's called a series. A series is simply an expression formed by adding the terms of a sequence. So here's an example of a sequence. 1, 3, 5, 7, 9. If we add all these terms together, then it becomes a series. So if I was to, let me put the plus on here, add, and add, then the expression I get for this series is 25. This one happens to be an arithmetic series because you're adding 2 to each term. We're going to focus more on geometric series, and the next one is an example of a geometric series where you're multiplying by 3 each time, and then we want to add these together to make it a series. So if I add these together, and there are many terms to this series, and I could take a calculator and I could add up 2 plus 6 plus 18 plus 54 and so forth. But surely there's an easier way that we can simply compute the series, the sum of it, rather than having to manipulate it with a calculator and just add all those numbers up. And so that's what we're going to learn today. So as you suspected, there is a formula to compute the sum of a geometric series. Now these would be geometric sequences that have a finite number of elements. So you know how many terms there are in the sequence. It cannot be an infinite sequence or we couldn't add it together. So here is the formula that, yes, you do need to memorize it. And we're going to use a capital S to represent series, sub n. So again, n is the number of terms in the sequence, equals a sub 1. So the first term in the sequence, and then we have these parentheses, and then we have a ratio here, a fraction. 1 minus r to the nth power. R here is our common ratio over 1 minus r. So in the numerator, notice it's 1 minus r to the nth power. In the denominator, it's just 1 minus r. So in order to use this formula, you need to know the first term in the sequence. You need to know how many terms are in the sequence. Usually you can just add those up, count them, actually not add them, but count them up. And then you also need to probably compute the common ratio. And then you can substitute in all those values and calculate the sum. So let's do an example. If you'll turn to page 617 in your book, we're going to flip around in your book just a little bit and look at the Your Turn number 6, where it says find the sum of the finite geometric series. So here we have the series that's given to us, and we want to find the sum of it. So let me start by writing down our formula. So we have S sub n equals a sub 1 parenthesis 1 minus r to the nth power over 1 minus r. All right, so let's see what pieces of information we have. A sub 1 is the very first term, and so that is a 1. N, well, how many terms are in the sequence? Let's see, 1, 2, 3, 4, 5, 6. So there are 6 terms, so n is going to be 6. And then we need to probably compute here our common ratio. So you're going to take two numbers. So I'm going to just take the second one and the first one. So negative 2 divided by the first number. I could have used 4 and the number before it, which is negative 2. All those are going to give us the same common ratio, which is negative 2. Now that we have that information, let's simply substitute in. So a sub 1 is 1, parenthesis 1 minus, now I'm going to put this negative 2 in parentheses, raised to the 6th power, all over 1 minus negative 2 in parentheses, and then another parenthesis. Okay, so let's see, as we simplify here, this 1 out front, that's just 1 times everything. That doesn't really help us any. So I have 1, and then I'm going to compute 1 minus -2 to the 6th power. That is 64 over 1 minus a -2, which is 3. And if I keep simplifying, that is going to give me -63 over 3, which simplifies to -21. So the sum of this series is -21. So finding the sum of a series is straightforward if you memorize this formula and you know what A1 is, you know how many terms, and you compute the common ratio. So we're going to take a look at maybe a little bit more challenging problem where you don't know one of these pieces of information. And that would be this one right here. Is maybe you don't know how many terms are in the sequence. So if you'll turn back in your book to page 616, we're going to look at example B. And with example B, and I'm going to zoom in here, we have a series of 1/4 plus 1/8 plus 1/16 plus, and then a bunch of other terms in here that aren't listed, plus 1 over 512. So this is finite, so it ends. We know the last term, we know the first term, and we know the second and third. So that's going to help us, we definitely know this first term, that we can compute the common ratio. What we don't know is, well, wait a minute, how many terms are all together? There's 4 listed here, but then there's some in the middle. So that's what we're going to have to determine, is how many terms are in the sequence, since it doesn't tell us. So let's go ahead and first write down the first term in the series is 1/4. So that comes right at the beginning there. All right, let's go ahead and compute the common ratio by dividing 1/8 by 1/4. Can you do that without a calculator? It would be 1/2. All right, so now we know those 2 pieces of information. Let's go after finding n. What we do know is we do know this last term. And we also know, since this is a geometric series, it is made up of a geometric sequence. And if you recall from our previous lesson on geometric sequences, okay, the sequence is given by a sub 1 r to the n minus 1 power. So this formula here from the lesson before this one gave us each term. So we can use this, set it equal to the last term to find out n. So that's what I'm going to do. So a sub 1 is 1/4, r is 1/2, and I have n minus 1, and I'm going to set it equal to 1 over 512. All right, let's go ahead and multiply both sides by 4. And that simplifies our fractions a little bit. Now we have 1/2 to the n minus 1 power equals 1 over 28. Okay, the way we're going to solve this is we're going to find a common base. So we're going to change 1 over 128 to a base of 100 or 1/2, so it matches. And that happens to turn out to be to the 7th power. And you might have to play with your calculator to figure out that exponent, because 2 to the 7th is 128. Now that they have the same bases, we can set the exponents equal to each other. So n minus 1, we're going to set it equal to 7. Add 1 to both sides, and we get n is equal to 8. All right, now that we have that information, I'm going to scroll down the page here, and let's go ahead and substitute into our formula for the sum of a series. So our a sub 1 was 1/4. Our common ratio was 1/2. And the number of terms was 8. And so now this is just a matter of carefully simplifying. Let's go, I would always recommend here that you apply that exponent first, and we get 1 over 256. Keep simplifying, that gives me 255. That's 1 minus 1 over 256. That's 255 over 256 divided by 1 minus 1/2 is 1/2. Simplifying inside, I get 255. Keep my page from moving. All over, let's see, that's 128. Multiply by 1/4 now, and I get 255 over 512. So this is the sum of our series. All right, let's look at page 617, your turn number 7. I'm going to get this problem started, and then I'm going to let you finish it. So here is our series. We do not know how many terms we have, but we do know that the first term, a sub 1, is 1/2. We can also compute the common ratio. So if we take -1/4 and divide it by a positive 1/2, we get a common ratio of -1/2. So we have that information. Now we need to go after, well, how many terms do we have? So we're going to use our previous formula for a geometric sequence, okay, that says a sub n equals a sub 1 r to the n minus 1 power. Okay, and in this case, what we don't know is n, but we do know the very last term. So we're going to let -1 over 256 equal a sub 1, which is 1/2, times the common ratio, -1/2, raised to the n minus 1 power. All right, let's go ahead and multiply both sides by 2. That way this will cancel, we can get that fraction out of the way, and so we end up with -1 over 128 equals -1/2 to the n minus 1. All right, now we've got to change the base for this 1 over 128. So we want it to be the same base that we have here. So I need to make it to a -1/2 base. Now what exponent do we need to get 1 over 128? Playing around with that with your calculator, it is 7, because 2 to the 7th power is 128. Equals -1/2 n to the minus 1 power. All right, now we can set these exponents equal to each other. 7 equals n minus 1. Add 1 to both sides, and we get n is 8. So we have n is equal to 8. We have our very first term in the sequence. We have our common ratio. I am going to let you finish this problem to find the sum of the series. Good luck.